Hi, welcome to another tutorial in my series on work done by a force. Now in previous tutorials we've looked at a particle moving in the horizontal sense and then in the vertical sense and looked at various forces and the work done by those forces. But now we're going to take our particle and look at the work done by various forces as it moves up a rough inclined slope at a constant speed. Okay? Something like that. Let's take our particle back down the slope again. Okay? Now this particle represents this package up here, a package of mass 3 kilograms. It's pulled at a constant speed up a rough slope inclined at 40 degrees to the horizontal, and the coefficient of friction is 0.3. If the package moves a distance of 10 meters up the line of greatest slope, what I want to show you is how we can find the work done against gravity and the work done against friction. So how do we answer that first question then, the work done against gravity? Well, we've already seen that work done by a force is equal to force times the distance moved. Well, it's not strictly true that it is distance moved, it's just I had to save space here, but it's the distance moved by the point of application of the force in the direction of the force, as we've seen in earlier tutorials. And when it comes to working out the work done against gravity, we look at the force of the weight here, okay, which is mg. And mg, the weight, acts downwards, so that's our force. And how far did that force move its point of application in the vertical direction? Well, as that particle moved up the plane, let's just do it again, okay, the 3g Newton force, the weight, went from the bottom here up to the top here. It moved what we call a distance h, a height h. Let me just return that particle to a general position on the slope. So when we talk about the work done against gravity, what we need to do is write in the height h, mgh, h being this distance up here. Okay? So how are we going to work out what h is? Well, because this is a right angled triangle, we can use trigonometry. We already have the hypotenuse, and h is the opposite side to the 40 degrees here. So that's going to be the sine of the angle 40 degrees. We know that the sine of 40 degrees equals the opposite side, which in this example is h, divided by the hypotenuse, which is 10. So if we multiply both sides by 10, we end up with h equaling 10 multiplied by the sine of 40 degrees. So that gets us our height. So we can easily fill this in now. Okay, we know that the mass is 3 kilograms, so we've got 3. If we take g to be 9.8, then the height h we've seen is 10 multiplied by the sine of 40. So let's just put that in there, 10 times the sine of 40 degrees. And if you work that out on your calculator, you'll get 188.97 and so on. And if we were to round that, say, to, let's say, 3 significant figures, that's going to be 189. And the units would be joules. So let's just put that to 3 significant figures. Okay, so that's the work done against gravity. The weight, mg, times the height that force, the weight, moved through. This particular quantity is called potential energy, but we'll have a look at that in another video later in a bit more detail. Now for part B, the work done against friction. How do we work that out? Well, we can see that As the particle moves up the slope, the frictional force F newtons is parallel to the slope. So the frictional force moves its point of application 10 meters. So the work done against friction will be F times 10, force times distance. Problem is, we don't know what F is. But because it's moving up the slope, a rough slope, friction must be limiting. F equals mu r, in other words. So, what is r? Well, to get r, all we've got to do is just resolve perpendicular to the slope. So if we resolve away from the slope as being positive, we're going to have r minus 3g cos 40. Cos 40 degrees there. And because there's no resultant force, it's going at a steady speed, then that must be equal to 0. We can rearrange this and get that r equals 3g cos 40 degrees. And if we work that out in your calculator, you'll end up getting 22.571 and so on, okay? And that'll be measured in newtons. Now, as I said earlier, we know that friction's limiting, so we know that F must equal mu r, coefficient of friction then times r. So coefficient of friction is 0.3. We know what r is, it's 22.571 and so on. Just multiply those two together and you end up with 6.756 and so on newtons. So all we need to do now then is do the work done against friction as being F times 10. Then the work done against friction is going to equal F times 10, 6.756 and so on, multiplied by 10, which is clearly 67.56 and so on. And if we round that, say, to 3 significant figures, we've got 67.6 joules to 3 significant figures, 3 SF. Okay? Well, I hope that's given you some idea then of how we can do work done against gravity, the formula mgh, and also work done against frictions in problems like this, and that you can use this as a backdrop then to examples similar to this that you might try. Okay, well, good luck with those examples, and as usual, that brings us now to the end of this video.